Boo! Happy Halloween. We've got a nice scary equation for you there. But do not fear, because much like a child in a ghost costume, this is also just wearing a costume. We can simplify this right down, and I'll show you how. So first things first, I'm sure some of you are a little bit concerned about this part here, because what is pi doing in here? Well, I'll tell you. This pi is not the pi that you're expecting. It's actually a kind of measurement for circles, for degrees. Instead of degrees, we use radians. And it's a very simple system that's derived from this bit here. You know, the circumference equals 2 pi r. Well, the radian is just the circumference over the radius. So as you can see in this case, this will be the radians for the full circle. So we see that 2 pi equals 360 degrees. If you were looking out, because it's a full circle because we've got the circumference there. So that's nice. So if we want to think about this, we would have to divide this by 4 to get what we're looking at here. And then we actually see that pi over 2 in radians, we can do it like that, is, let's just put, you can refer to it like a little c at the top there. That's the radian symbol. Is actually just 90 degrees. Which is, you know, that's good for us. Because we can just convert that straight into, you know, we can do our inverse operations there. So if you look, what we're looking at here is actually 1 plus tan squared over 90 minus theta, if you want to think about it like that. Then, right, so now that we've established that, let's do some conversions here. So 1 plus sine squared that angle over cos squared that angle, because, you know, that's our first property, tan equals sine over cos. And this part, I'm actually not going to do that for you, because it's too sneaky, because this is one of our square identities. 1 plus tan squared is actually equal to sec squared. You can prove that using Pythagoras. So I'll do that now. Quick sticks, just to clear it up. So let's say this is our square. This is on a Cartesian plane. Let's say this is our triangle. Sorry. This will be our radius if we're drawing a circle, whatever. This is our radius, and then this is y, and then this is x. Now, so as we can see in our Cartesian plane here, if this is the r, and this is the y, and this is the x, if we've just drawn a line in a Cartesian plane at a right angle, we know that x squared plus y squared equals r squared from Pythagoras. Now, we know that tan is y over x, so if we were to divide all of these terms by x squared, we can see here that that's 1, that's tan squared, and what does that give us? Oh, well, don't you even worry, because that's sec right there. R over x, the inverse of cos. And there you go. So that's how we got this part here. Now, here we're going to do a little bit of a swap around. We're going to do a switcheroo, if you will, because we know that when you are faced with a situation where it is sine 90 minus theta, you can change that sign to cos theta, and you can change cos theta to sine theta, just like that. So that's some good stuff. Right, now, I know it doesn't look like we've done much, but we really have. We've whittled down our equation quite a lot here. So what we can see is that this is the inverse of tan, because tan is sine over cos. So that's actually just cot over sec squared. Now, remember we were trying to prove some of these identities. Well, I've got a sneaky little surprise for you. This is actually another one of our identities. And so let's do that one quickly. X squared plus y squared equals r squared. Now, if we were to divide each of our terms by a y, then we get cot squared plus 1 equals to cosec squared. And that is the inverse of sine, because it's, sine is y over r, this is r over y. Okay, so now we just stick that in there, cosec squared theta over sec squared theta. Now, if that's a little complicated for you to work with, remember these are just inverse of each other. So if we swap those around, okay, let me put this another way rather. This is 1 over sine squared theta divided by 1 over cos squared theta, because those are the inverse of our trig identities there. Okay, so when you work that out, you get cos squared over sine squared, which we now know is just cot. So cot squared. So isn't that nice? Look how tiny that is. Have a good Halloween. Yeah.